Hello, welcome to the first in our series of videos where we solve the questions in the WASSCE 2020 Dec Core Math Paper 1. In this video, we're going to solve the first 10 questions, and we begin with question 1. Here we are asked to simplify correct to 3 significant figures. This product, 0.0023 times 0.577. What you can do here is to punch this into your calculator and see the result. And when you do that, on my calculator, I got 0.001323271. So having got this result, you now want to round it off to 3 significant digits or 3 significant figures. And when doing that, what you have to note is that all the zeros that precede the first non-zero number, which is 1, are not significant. So the first significant digit we have here is this 1. Then the second one is 3, and then the third one is 2. So our numbers should be ending here. However, because the number that comes after 2 is greater than or equal to 5, in this case it's 7, we have to bump up this 2 to a 3. So that gives us this number, 0.00133. The reason these zeros are not significant is that if we wrote this number in standard form, you can imagine we would have to move the decimal point 1, 2, 3. So we get 1.3721 times 10 to the minus 3. So in a way, we've expressed this number in another way, excluding all the zeros, but we couldn't have done that without bringing all the non-zero numbers, or if you like, all the numbers that come after the first non-zero number and including the first non-zero number. So those numbers are significant, but the zeros that precede it are not. The next question is to express 245 base 6 in base 10. When we have to find the actual value of a number, we have to take note of the place value of all of its digits. So here we have 2 times something to the power, 2 times 6 to the power something. We're going to write the power later. Then we have 4 times 6 to some power, and then we have 5 times 6 also to some power. Now we start writing the powers this way. It's convenient to start from the right and go back to the left, and then we simplify. 2 times 6 squared, 6 squared is 36, times 2 is 72. Then we have 6 to the power 1 is 6, times 4 is 24. And then we have 6 to the power 0, that's 1, times 5 is 5. So doing this sum, 72 plus 24, that's 96, plus 5 is 101. So that's our answer. The next problem is question 3. It says, given that x equals 3 and y equals 2, evaluate 4x plus 3y mod 8. Now let's do 4x plus 3y in the ordinary way. That gives us 4 times x is 3 plus 3 times y is 2. So what do we get? 4 times 3, that's 12. 3 times 2, that's 6. So we get 18. Now the question is, what is 18 mod 8? So 18 mod 8 equals what? Now when we are writing a number mod 8, we are trying to subtract as many multiples of 8 out as we can from it to see the remainder. And if we notice that the multiple of 8 that is closest to 18 is 16, then 18 mod 8 will be equal to 18 minus 16, which is equal to 2. So that's our result. The next problem, we have a question in indices. We have to solve for x in this indicial equation. Now 1/4 or 1/4, if we remember the relationship between 2 and 4, we know that 2 squared is equal to 4. So 1/4 is the same as 2 to the power minus 2. So substituting 2 to the power minus 2 into the equation, we get 2 to the power minus 2 all to the power x is equal to 2 to the power 3x minus 3. Now this gives us 2 to the power minus 2x equals 2 to the power 3x minus 3. Equating the indices, because the bases are the same, we have minus 2x equals 3x minus 3. That means that 5x is equal to 3 and x equals 3/5. So that's our answer. The next problem is question 5. Given that log of log x equals 0, find the value of x. Now, whenever the log of something is equal to 0, what do we know about the thing? We know that that thing must be equal to 1. So if log, let's call that number m. If log m equals 0, then m equals 1. This is because, in fact, in this case, our log is to the base 10, but when logs are to the base 10, we don't normally write the 10. But what this means is that 10 to the power 0 is equal to something. That's basically what it means. So you are looking for the number, how to put it. When you have log 10 to the m, it means that 10 to the power 0 is equal to m. Now any number to the power 0 is equal to 1. So that's how we get that. And so it doesn't even matter what the base is. Whenever you have a log of some number being equal to 0, that number must be 1. So that's the idea we're going to use here, that if log, let me write it here. So if log of log x equals 0, then this implies that log x is equal to 1. Now if, like I said, this log is actually to the base 10. Now if log 10 of some number x equals 1, what can we say about x? That's another thing we have to know, that it means in this case that this implies, let me write that, x equals 10 to the power 1, which is equal to 10. Now again, you remember the definition of log, that when you have log to the base a of b equals c, if you write this, the equivalent indicial equation is that a to the power c equals b. So that's the idea we've used here, and so our answer is C. The next question is question 6. Here we have this Venn diagram, and we're supposed to use it to find this set, which is the complement of x union z, x union z. We intersect that with y. So first we can think of x union z. X union z is all the things in this is x, so all the things here and all the things here. So that, if you like, all the things here with all the things here. So everything here is included except 8, 10, and 11. Those are the only things that are not in this union. So that is what the complement is. The complement is the things that are outside it. And from the diagram, the things that are outside it are 8, 10, and 11. So if we're now intersecting that with y, we see that of 8, 10, and 11, the only thing that is in y is 8. So that becomes what the set is. Okay, the next problem is question 7. It says, find the sum of the first 6 terms of the geometric progression, or GP, half, 1, 2, 4. Now in this geometric progression, what can we observe? We can observe that the common ratio is 2. In other words, to go to the next term, you multiply by 2. Half times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. So the next term is going to be 4 times 2, which is 8. And then the next term, 8 times 2, which is 16. So the first 6 terms of this GP are 1, 2, 3, 4, 5, 6. Half, 1, 2, 4, 8, 16. And we are supposed to add all these numbers. Let's try to do that. We have 16 plus 8, that's 24. We add 4 to that, that's 28. We add 2 to that, that's 30. We add 1 to that, that's 31. And then we add half to that, that's 31 and half. So our answer is B. The next problem is question 8. We have to simplify this. Now, if you look at the options we've been given, we see that they all don't have a denominator, if you will. So we can also try to get rid of our denominator, and the way to do that is to rationalize. So we multiply both the numerator and the denominator by square root of 2. And what do we get? Well, for the top, we get 2 times square root of 3. If we multiply them by square root of 2, we get 2 times square root of 6. And then that multiplies 3 times square root of 2 minus 2. And then for the bottom, we get square root of 2 times square root of 2, that's 2. So we simplify this further. We can divide, cancel out this 2. We get square root of 6. Square root of 6 times 3 square root of 2 minus 2. We can expand, and then we get 3 times square root of 12. Square root of 6 times square root of 2 is square root of 12. And then we have minus 2 times square root of 6. So simplify further. Square root of 12 can be simplified as square root of 4 times square root of 3. Now when we write it that way, because square root of 4 is a nice round number, an integer, it helps simplify the surd. So we have here this. Now square root of 4 is 2, so that 2 multiplies 3, we get 6. So we get 6 root 3 minus 2 root 6. Looking at the answer options, that appears to be A. So that's our answer. The next question is question 9. It says 2 numbers are in the ratio 3:5. If one of them is greater than the other by 10, find the smaller number. So we have, let me rewrite this ratio, 3:5, and we have some 2 numbers. One of them is greater than the other by 10. So if the smaller one is n, then the bigger one is what? Is n plus 10. And we are supposed to find the smaller number. So we are supposed to find n. Now what can we do? We know that n over n plus 10 is equal to 3/5. So we can cross multiply. that gives us 5n. 5n equals 3 times n plus 10. That's 5n equals 3n plus 30. And then we have 2n equals 30. So that implies that if 2n equals 30, then n equals 15. And n is the smaller number, so we have that. Now upon obtaining n equals 15, you can find n plus 10, and you'll see that n plus 10 is 25. So we have 15 is to 25, and the question is 15 is to 25 equal to this? And the answer is yes, because you can divide both by 5. If you divide 15 by 5, you get 3. If you divide 25 by 5, you get 5. So the ratios are actually the same. The next question is question 10. This is going to be the last in our series of questions for this video. It says if x varies directly as the square of y and x equals 45 when y equals 9, find x when y is 6. So we are told that x varies directly, so we can write this: x varies directly as the square of y. So this is the relationship between x and y. And then we can write an equation by introducing a constant. So if we introduce a constant of proportionality k, then we have x equals ky squared. We are told that when x is 45, or x is 45, so let's write 45. X is 45 when y equals 9, so k times 9 squared. It means 45 equals, what's 9 squared? 81. So 81 times k. And what does that give us? It gives us k equals 45 over 81. And what is that equal to? That's equal to 5 over 9. We divide both the numerator and the denominator by 9 to get this. That means that the relationship, this x equals ky that we wrote, we can now put the real value of k there. It means that x equals 5 over 9 times y squared. That's the relationship between x and y. So now we are supposed to find x when y equals 6. So let me change pens. We write when y equals 6, what do we have? We have x equals 5 over 9 times 6 squared. Now 6 squared equals 36, but let me just write it down so that it's easier to see. So 5 over 9 times 36. Now 9 divides 36 to give 4. So we have x equals 5 times 4, which is 20. So that's our answer, B. Alright, so we've come to the end of the video. We've solved the first 10 questions. In the next video, we're going to continue. We're going to solve the next 10 questions, and we'll do that to the end. See you then. Bye.